Hello everyone, today we will be continuing our probability unit, and this time we are going to be following our compound events. And our compound events is a probability of two or more simple events. So two or more simple events, that's what it says right here, two or more. And so there's two types. The first type of event is called an independent event. And this is when the outcome of one event does not affect the outcome of the other event. And so the formula for that says the probability of A and B happening is the probability of A multiplied by the probability of B. And so this is kind of confusing. Let's put it into practice. It's a little bit simpler to see. For example, in number 11 it says a die is rolled 3 times. What is the probability of getting ones on each roll? So the reason why this is an independent event is because once you roll a die, that has absolutely zero effect on what happens when you roll it the second time. Nothing changes, no probability changes, and therefore it's an independent event. So let's think about this a little bit more. So we have a die, and the chances of getting a 1 on a die is actually 1 out of 6, because there's 6 sides, there's only one 1 on there. So that's the first time. But we do have to multiply it by the probability of the second event, or the third, or the fourth, and so on and so forth, depending on how many times you are asked to do it. So here it is 3 times, so that's my first time. My second time, still nothing changes. That's still going to be a 1 out of 6 chance of rolling a 1. Now for my third roll, again, whatever I got these first 2 rolls, it does not matter. So for my third roll, the chances of me getting a 1 on a die is still 1 out of 6. And so when we do these, we line them up, and then we will be multiplying straight across. So 1 times 1 is 1, times 1 is still 1, over 6 times 6 is 36, times another 6 is 216. So our answer here is 1 out of 216. I think it's a little bit easier to see in number 12. So number 12 says a coin is tossed, then a day of the week is selected. What is the probability of getting tails and then a day starting with the letter T? So again, this is independent because whatever happens in probability A, so in this case the coin is tossed, that's my A, and whatever happens to B, my probability of my second event, which is the letter T, it has no effect on each other. It doesn't tell me, well, if you land on heads, then you have to choose, Monday. Or if it lands on tails, then you have to choose Tuesday. No, these are two independent events. They do not affect the outcomes of each other. So for my probability of A, that's going to be a coin toss, so getting tails, that's 1 out of 2 options, multiplied by the choice of days starting with the letter T. So that's Tuesday and Thursday, that's 2 out of 7 in total. You do multiply straight across just like you did before. 1 times 2, that is 2. 2 times 7, that is 14. However, anytime that you can simplify, you should be simplifying. And so while 2 out of 14 is a correct answer, the actual answer would be 1 out of 7. So that is as simple as you can get. So let's look at this next problem. So this next problem says a bag contains 8 red crayons, 14 purple, 6 yellow, 4 green. A crayon is selected, replaced, then another is selected. Find each probability. I want you guys to either box or highlight the word replaced. That's going to be one of those independent event kind of keywords. So what they're saying is you have this bag of crayons, right? You take a crayon, but you put it back. That means nothing has changed for the second or the third probability that you want. That's why it's an independent event. And usually you're going to see replaced, and you will be doing independent events. So we have a bag containing 8, 14 purple, 6. Okay, so in total that is actually going to be 32 crayons. So I added up 8 plus 14 plus 6 plus 4. So then it says the probability of purple, then yellow. So this is going to be A, and this is going to be B, and it's always going to be in that order. Follow that order. That's going to matter eventually. So for probability of purple, that's going to be 14 out of 32. But I put that purple crayon back, and so then I want to choose a yellow one. So that's going to be 6 out of 32. Going to multiply straight across, and that in its simplest form is actually going to be 21 out of 256. Let's look at two purples now. So two purples, I take one purple, that's 14 out of 32. But I do put that purple crayon back. So when I go in to do my second choosing or go in to reach for another one, it's still going to be 14 out of 32. Nothing has changed. These two are independent events. So I would say 14 out of 32. So we multiply straight across, and I think that's like 196 over 1024, which in its simplest form ends up being 49 over 256. Okay. But now let's look at dependent events. And so dependent is when the outcome of one event does in fact affect the outcome of the other event. So we saw this one slightly different. So we have the probability of A and B happening is actually the probability of A. So we're always going to leave the probability of A alone. So whatever first they tell us, whatever first probability they tell us, that's always going to be A. Leave that alone. But we have to multiply that times the probability of B after A happens. So B after A happens. So let's take a look at some of those examples. So we are actually going to keep using that same bag with those same number of crayons. However, this time for dependent, it's going to say that once a crayon is selected, it is not replaced. So I want you guys to box that or highlight it. That's going to be one of the keywords for dependent events. So what they're saying is we have this bag. We take a red crayon or a purple crayon, whatever crayon that we want, and we will keep it. We will not return it to the bag. And because we're keeping it, because we're not keeping that same number of crayons in the bag, the probability for the second event, for P of B, that's going to change. So here we have my P of yellow, then red. So of course, please keep A and B in the order that they tell you. That does matter eventually. So the probability of yellow, that's going to be 6, and we did say that was 32. So we leave A alone, remember? P of A, leave that alone. Just 32 crayons. However, we keep one of those yellow ones. So what happens here is that there's no longer 32 crayons in the bag. Now there's only 31. But then we do want a red crayon. So for red, that was 8. So now the probability of choosing a red crayon out of the bag is 8 out of 31. Still, we multiply straight across, and once we do that, we simplify it. And in its simplest form, this is 3 out of 62. Let's look at P of 2 reds. So the probability of 2 reds, the first time, my P of A, that's my first red, that is going to be 8 out of 32. However, we keep that red crayon. So now there's only 31 crayons in the bag for my second probability, which is yet another red. Keep in mind we have one already. So this actually becomes 7 red crayons in the bag out of 31 in total. So we multiply those straight across, 8 times 7, 32 times 31. And in its simplest form, we have 7 out of 124. So I've simplified this quite a bit to get to 7 out of 124. So let's look at number 22, and I'm going to cross this out. There's only 8 Mars bars. We're not doing 88 of those. So it says Jack had 4 Snickers bars and 8 Mars bars. So 9, 10, 11, 12. We have 12 here in total. He randomly chose a piece of candy, ate it, then chose another. What is the probability that both candy bars were Snickers? Okay, so he ate that candy. That means he did not put it back. Now we have less number of candy the second time around. So the first time, my P of A, the first time that I chose a Snickers, I had 4 out of 12. That's what it tells us here. However, that second time, we had not only 1 less candy bar, we had 1 less Snickers as well. So instead of 12, now I had 11, and instead of 4, now I have 3. So even though it's tempting to say, well, they're both candy bars, so I took them both at the same time, they're not at the same time. We take one, then we take another. So we multiply straight across here, and in its simplest form, that's going to be 1 out of 11. So this is, of course, not what I got when I multiplied it straight across the first time, but we did simplify and simplify and simplify until we could no longer. So if you have any questions about this, please come see me in B Lunch and we'll get those answered for you.